Okay, so good afternoon to all. Today,
Sir,
good afternoon. Good afternoon. Today we'll start basically assignment number one with some introduction on your dimensioning and some lettering and numbering. Then we'll start problem number one. Okay. In the last class, I told you regarding the instruments and all. That means which things you have to buy, and regarding the subject, the syllabus, and the assignment. All things were discussed in the last class. So let me share my screen first. Is it visible?
sir.
Yes, sir.
Okay, thank you. So you see, uh, let us start with very important and this thing you should know. That means this your dimensioning of the papers. In the last class, if you remember, I told you that generally in our lab we use this A1 drawing sheet. Okay, this A1 drawing sheet, and generally often for writing any letter and all we use this A4 size paper, right? You have heard, I think, this term. Okay, this size A4. But what is the size? Actually, the as this number is going down, you can see starting from A5, A4, A3, A2, the size is getting bigger. Okay, the size is getting bigger. So it starts from basically your A0. Okay, and how the size you can find a particular fashion so that it is getting the size is getting reduced. If you see, this is the say A0. Okay, A0 size paper. This one, and this size you can see 841 millimeter multiplied by your double one your 89. So if this is the size of A0, this is the largest one. So A0, if I just cut into two pieces, you can see. Okay, this is the length. This 1189, this is the length of the paper, and 841 is the width. Say, so if I cut it like this through this line, and each of the part is getting like this, okay, that size is basically your A1 size. Okay, so in the same fashion, actually it is divided into two equal parts in length. If you see the length is getting half. Okay, and that when the length is getting halved and the width of the earlier size, this was the width of the earlier size, that is now getting the length of the next size A1, the corresponding next size. You can see this was 841 was the width of this your A0 size paper, and here you can see the what is the length. This is the length here. Okay, length of your A1 size. So often it is asked in the Viva what is the size of the A1 drawing sheet. That is your nothing but 594 millimeter and your 841 millimeter. So obviously this 841 is the length and 594 is the width. So this size you keep in your mind, not for all, just at least your A1 size. And in the same fashion, you just see the figure, same fashion here. Now if I cut into two pieces this length, this is the length of this A1 drawing sheet. If I take two equal pieces, that means if I divide this length uh, into two equal parts, so I am getting A2 size paper. Okay, then this width of this A1 is getting the length of this A2 paper. Okay, so similarly it is going on, and A4 size, whatever the A4 size we use, that is your 210 multiplied by 297. Okay, this is the approximate size. In actually you may find your 1 or 2 millimeter your difference, but this is a standard size. Okay, so A1 is this one size, but as we are not using this your A1 drawing sheet as of now, we may have been used something in between A3 and A4. Whatever the sketchbook you are using, it is not A4, it is bigger than A4, but it may not be A3 also. Okay, so but you should know the size of this sheet, A1 drawing sheet. Okay, so this is basically the size. Okay, you can take a screenshot of this so that all the sizes you can get, or you can get it from your internet also. So next thing is the lettering and numbering. Okay, lettering and numbering, you may think why sir is showing ABCD and 1 2 3 4 and all. Basically all of you know this from your childhood. But here the thing is that whatever you are writing on the drawing sheet, say you have drawn something, any particular drawing, and you are writing the name of that drawing just at the bottom. So when you will write, first thing keep in your mind, uh, all the things whatever you will write, all the words and all the fonts whatever you will write in capital letter. Okay, no small letter will be allowed. That is the first thing. Now, second one is when you are writing, say in capital, you are writing cycloid. One particular curve name is cycloid. So CYCLOID. You will write this all capital letters, and this should be the fashion of writing. Okay, in capital letter, the lettering should be. You can see the 5 units is the height. You can see. So this is a standard height, but also this again depends on the size of your drawing also. But what my point is, whatever you will write, each of the font you can see A, B, C, D, each of the font is having the same height of your 5 units. So 5 units, if I am taking 5 millimeters, say for example, so all height of the all the fonts should be your 5 millimeters. Okay, if someone is writing A in this large manner and B as a smaller, and just do not try to give any design or any type of style. Okay, that is those things are not allowed. These are all your formal writing will be there. Okay, and so all the fonts whatever you will write, it will be just like this. No other designs are allowed, no other styles are allowed. Okay, you may use those things in your conventional your picture drawing, but not here. So here you can see some exceptions are there. You can see if this is the 5 units, the this part is your 4 units. You can count the boxes, you can count the box. So one box is 1 unit, so 1 2 3 4. Here also 1 2 3 4. Exception is for F, 3.5 units, you can see. Okay, height is same for all. For J it is my 3 units, and 5 units and 5 units both will be 5 units for M and W. Okay, for this M and W, both will be of your, that means length and height, both will be of your 5 units. But yes, it is not possible all the time to measure each and every, that means how much it is 3.5, how much it is 3. But at least try to, but just after writing you can see that if all the fonts are of same, are getting same size or not, that you have to check. And my suggestion is how to do this very easily. Just you draw two parallel lines. Okay, say that just the top line and the bottom line, whatever the space you are having in between, if you write in between those two lines, automatically whatever you will write, all the fonts will be all getting of same height. Okay, that is the easiest way to do this thing. But whatever the lines, two lines, the topmost line and the bottommost line you will draw, those two lines should be very thin. Okay, very thin. I may not see that, you can see that. So that is for your reference, that you just draw two lines so that whatever the space in between you are having, that should be equal, provided these two lines are parallel. Okay, these two lines should be parallel. So that is basically my main goal in this slide, to make you understand that whatever you need to write in the in your drawing sheet, use, always try to use pencil and use capital letters, and all the capital letters should be of your same size. And same for this fonts also, that means this letter, the these numbers also, 1 2 3 4, some values you have to write, some calculation you may have to do. So those things you have to use in the same fashion. That means say for example, in yeah, just roughly we write 2 like this, right? But engineering 2 is something like this. I'm trying to show you here. Okay, you can see this 2. Okay, so this is,
Sir,
yes.
sir, really sorry to disturb you. One student is having an internet issue, so he could not join the class. He's trying now. Can you allow him?
Wait, Oyan Bhattacharya. There are so many people. Okay, please try to join within the time from the next class. Otherwise, it breaks the concentration of the class, right? Okay, so you can see the slide, right? Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, okay, thank you. So this is basically my main point of concern in this slide, that just try to write in this formal fashion. Whatever writings, that means the lettering and the numbering you're writing, and all the fonts and the letters and the numbers should be of your same size. Okay. Next, you have to learn something, basics of the lines, types of lines. Okay, this is important for your Viva also, that which type of line we have to use. You can see different types of lines, but whatever you will need, I'll try to discuss those things quickly. Uh, First one, you can see continuous thick line. Okay, you can see the representation, continuous thick line. What is the use of this? Visible outline and the boundary line. That means the outer line of any object, outline, the border line, okay, the main outline of the object. There may be some inner parts of that particular object also, but the outline should be of your thick, okay, by this continuous thick line. Next is the continuous thin line. This may be the dimension line, extension line. There are different types of lines names you can see over here. I will explain these things. That means what is dimension line, what is extension line, what is construction line, and all those, what is leader line. Okay, so there, that means except, you can just take a note that except the object outline, whatever the lines you will use, that may be your continuous thin line. Okay, next, third one, you can see continuous thin wavy line, something like this, wavy. Okay, it is like a curve. So short break lines or irregular boundaries, that means whenever I'm having some irregular surface of any object, or short break lines means, basically when I'm having a very thin, say for example, I'm having a long, say your plate. Okay, long, the plate, that means the length of the plate, say I'm having a metallic plate. So length of the plate is much much higher compared to the thickness. So then the thickness will be defined, that means thickness will be denoted or shown by this type of short break line or the wavy line when I'm having a very small dimension. Okay, just opposite is the fourth one, the continuous zigzag line. Okay, you can see like it's like a heartbeat. Okay, you can see this type of line, you may have seen in some cases, but actual engineering application of this type of the zigzag line is that long break line. That means I'm having a very long length I have to show in the drawing. So in between, that means this, that basically long line can be shown by this type of zigzag. That means straight, then again that means you zigzag, then again straight, then again zigzag. In a some part, just at the middle, you can just, if you show like this, then I will understand that the length that you are denoting, that is very long. So basically it is by your long break line it is known. Okay, and the type is zigzag type. Next two lines are very important, 5 and 6, mostly used. Short dash line or simply dash line it is called. Okay, you can see dash, that means line, then one gap, then again a small line, then again a gap, just like a dash. This type of line use, you can see it's a hidden line. Whenever you will discuss from assignment number 2 the orthographic projection, then there will be some parts of the object that you cannot see, you may not see from your side, but some inner parts are there. That means those parts are hidden, okay, inside the object. So whatever the edges or parts are there that is hidden, that you cannot see from your side, but the part is there inside the object, those type of hidden edges are denoted by this type of dashed line. Okay, so it's say how we will draw, just for example I'm telling you, just say for example 2 millimeter continuous, then 1 millimeter gap, then 2 millimeter continuous, then 1 millimeter gap, something like this. That means each of this length of these lines, small small lines, should be of same. Okay, that you can do by your own method, but there should be, the gap also should be same. Your one gap is very large, another gap is very small, that is not allowed. Okay, you can see it is a totally uniform type of gaps and your lines are there, so it's your dashed line or it is called your hidden line. Okay, next is your long chain line. Basically this line and this line is basically, it looks same here, but let us see this sixth one. Okay, this long chain lines, here it is generally, this name is very popular. Let me uh, take over here. This is the center line. It is not getting, sorry. The center line, the center line that you can see over here, center line, yes, the center line, that term, this term is very popular. So you can see there is a difference between this fifth one and sixth one. The fifth one I told it's my hidden line or dashed line. Okay, next one is my center line. So it is my line dot, then again line dot, then again line. So this center line, what is the significance, where it will be used? Okay, someone is trying to enter right now, but I will not allow. Sorry, don't request me. So here you can see the line, then dot, then line, then dot, then line. So this line is your center line. Okay, it is basically, the significance of the center line is nothing but the axis of symmetry of any object. Okay, say I am having just your circle. Okay, or I am having a cylinder. That means, just if I am having a cylinder or I am having a cone, there should be a axis of that particular object. So that axis of that particular object will be denoted by this center line. That means line, long, just a bit long line, then dot, then long line, then dot, then the same it will go on like this. So this line is known as your center line. Up to this 1 to 6, is there any doubt? I'm just showing you the type of line, how it looks like basically. I'll show you the application. Is there any doubt?
Yes,
Okay.
Sir, excuse me, sir.
Yes.
Sir, is that a hyphen or a dot, sir, in the long chain line?
It is basically, you can use dot, not an issue. Okay, you can use hyphen also, but again, if your size is very small, if your drawing size is very small, you cannot use hyphen. Then you can use dot also, but you can use small hyphen. If you are using hyphen also, you can use small hyphen. Okay, that is also center line. Okay, not an issue. Okay, next,
Can you please explain the number 2 and number 3 again?
number 2 and number 3. Okay, number 2 is, now it is very simple. That is my continuous thin line. Okay, that means that just whatever you will draw, except the outline of any object, whatever you will draw, that is my drawn by continuous thin line. There is a difference between these two lines, is the thickness, nothing else. Okay, you can see the difference is in thickness. So thick line will be only in the main boundary of the object. Other parts will be by continuous thin line. And wavy line will be not that much of used in your case, but still you have to know, you may have to use in some cases. It is my short
sir.
break line. Yes.
Sir, will you provide this PDF later?
PDF means this lecture I will share. Okay, I'm not going
Thank
to
you, sir.
share this PPT, but this lecture I will share after the class. Okay. So this short break line, someone was asking, this continuous wavy line, basically when I'm having very small dimension compared to the adjacent dimension. That means I'm having, as I have given one example, I'm having a metallic plate. The length is very long of that particular plate, and the thickness is very small compared to the length. Okay, that is very obvious. It is very thin plate. If it is, then that thickness in the drawing should be denoted by this type of wavy line. Okay, I'm showing you these things in a particular figure. Okay, if I show you,
Sir,
that
I
will
have a
be,
doubt.
yes.
Sir, in the fifth point, the short dash line, then it will
Hmm.
depend only upon the size of the paper, I think, sir.
Yes, yes,
If
size
it
of your
is,
drawing, size of your drawing basically, right? But this gap should be uniform. Whatever the size of this small line will be, that is not a big deal. But try to draw, as I told, 2 millimeter continuous line, then 1 millimeter gap, then 2 millimeter continuous line, 1 millimeter gap. Small gaps will be there, and small lines will be there. That is the hidden line. Okay. So next I'll show you that these dimension lines, extension lines, construction line, these things, and along with these hidden lines in a particular figure. Let us see. This is one machine component, and this is the front view. This is the front view of that object, and this is the top view of that object. Okay. So if I see these two figures, you can see there are different types of lines already, you know. Okay, that I have just discussed in the last slide. You can see those lines over here. Okay, first one you can see, this is A1. This first one is the outline. That means you can see this is a thick, okay, thick line. Outline means the whole outline of this object will be a bit thick. That is the object outline. Okay. Next, you can see one hidden line over here. Okay, that means line dot. Sorry, line gap. That means dashed line. You can see. That means there is a particular edge at the back. I cannot see that. Okay, from my front, as this is my front view. So what is front view and all that will be details. That will be detailed. There will be detailed discussion of that in your assignment number 2. But as of now, you just keep in your mind that whatever part you cannot see, that will be denoted by hidden line. Here also I am having some hidden line, okay, dash type of line. So these parts are not visible to me from my side. And center line also you can see here. Center here actually there is a circle you can see. So circle, this is the center of the circle. So circle is symmetric about this vertical line also and this line also. So that's why basically these two types of center line has been drawn. You can see these are the center line. So line dot, line dot, line dot, and it will go on like this, and this one also. Okay. And this cutting plane line I am not discussing right now. It will be discussed in the assignment number 3 when I will discuss the section of solids when I'll try to cut any object. Other lines, very important here, the dimension lines. Okay, see carefully. These dimension lines basically to denote the length. Say I have to denote the length of this part. That means from this point to this point I have to denote the length. I have to write the length. I have to give the dimension basically. Say it is my 90. 90 is written means 90 millimeter. Okay. No units should be written over here. Only value in terms of millimeter. So first thing, how to give the dimension? First thing, from this edge point, to this edge point, I want to give the dimension. So from this edge point, I will drop down a vertical line, small vertical line. From this edge also, I will drop down a small vertical line. And here you can see it is already you're attached with that particular edge point, but there should be a gap, okay, 1 or 2 millimeter gap, okay, and then you draw this vertical line. Okay, it should not, this vertical line, small line, it should not touch this edge point. Okay, there should be 1 millimeter gap, and then you draw this vertical line. These two lines are known as, you can see here, extension line. Okay, these two lines, whatever I have drawn right now, these two lines are known as your extension lines. In between these two lines, you can see I have drawn a horizontal line like this. Okay, this line, that is known as your dimension lines. Okay, this is my dimension line, you can see. And at the end over here and here, you can see two arrowheads are there. That means from this position to this position, I want to give the dimension. Okay, so I'm repeating the last step. First, from this point to this point, if I want to give the dimension, drop down the extension line first. Okay, small vertical line. In between those two extension lines, there will be a dimension line. Okay, okay. It should not cross this extension line. Okay, or it should not be shorter. Okay, it should touch this extension line and this extension line also. So once you have drawn perfectly parallel to the object, you have drawn this dimension line, above which I have to write the dimension at the middle. It is not, you should not write somewhere over here, you should not write somewhere over here, you should write at the middle and above the line, not below the line. Okay, that is the way of dimensioning. In the next slide I will show you much more about the dimensioning. There are two ways of dimensioning, but as of now you just keep in your mind that this, in this way you have to give the dimensioning. And these are the lines are called extension line and your dimension line. Okay, another thing is your this leader line. Okay, leader line is basically used to denote, now see, whatever this 90 mm whatever I have shown, that is for linear dimension. Okay, this linear dimension. But you have, if you have to give the dimension of this circle, the circle, this dimension can be given in terms of diameter also or in terms of your radius also. Okay, so if you want to give the dimension of this type of circle, circular part circle, then you have to use this leader line. You can see how to give. First, you just this is the center of the circle. Through this center you draw a line like this, an inclined line. Okay, any angle you just draw this inclined line. At the two end part you draw these two arrowheads. Okay, that will touch the periphery of the circle, and extend that line outside the object. extend that line straight by using your scale outside the object. Take it outside the object. Okay. Then you draw a horizontal line, small horizontal line like this. Okay. Above which you have to write the diameter. What is written over here? Phi 10. Phi stands for the diameter. Okay. Phi stands for the diameter. Phi 10 means my diameter is how much? My
10
diameter is how much?
millimeter. 10 mm.
10 millimeter.
Okay.
10 millimeter.
Actually, it is denoting this. This is the part. This is my 10 millimeter. But I'm not supposed to write this 10 millimeter dimension inside this object. Any dimension you have to give outside the object. Okay. So this actually this line leads the dimension. That's why it is called leader line. Okay, so these things you have to be very clear. Okay, these types of lines you have to be very clear regarding the use. When you are giving the dimension, you need not to write this is the dimension line, this is the extension line. These things you need not to write, but this here it is written for your reference. Okay, and in this way you have to give the dimension. And here you can see the long break and short break part. Okay, you can see this is also a machine bed, and where you can see there is a zigzag part. Okay, here also one zigzag, here is one also zigzag. That means this part is very long. Okay, that I have to think. And compared to this length, the thickness of this plate is small. Okay, compared to the length. That's why it is denoted by short break line. The thickness of the plate is my short break line. So these two will be not that much of use, but you have to know these two terms. Majorly you will use this dimension line, extension line, center line, hidden line, and this leader line. Okay, to denote the dimension of the circle. Clear up to this?
Yes.
Okay. Next, you see the placing of dimensions. That means there are two types of dimensioning, but you will obviously follow any one of these two. Okay, aligned system, there are two types of dimensioning basically: aligned system and unidirectional system. Okay, there are two types of dimensioning. So aligned system is the first one, or the dimensioning that I have shown in the last slide. That is your aligned system. Okay, you can see here I am having an object, different lengths I have shown. You can see I'm not repeating the same here you can see from this edge point to this edge point I have to give, there is a gap. Okay, you can see this vertical line is nothing but the extension line, and this is the dimension line above which I have written. So different dimension has been shown. This is the horizontal dimensioning part. Okay, horizontal dimensioning part. And the same thing you can see for the vertical dimensioning also. But here you see carefully that whenever I am giving the vertical dimensioning, so this vertical length is my 60. Okay, 60 means 60 millimeter. So from this point to this point it is my 60. Okay, so here I have given one extension line, here I have given one extension line, in between I have placed the dimension line. Now now where I have to write this value? Okay, that is the question now. The rule is from your right above the line. I repeat, from your right, that means this is the direction. Okay, this is the direction. Okay, this is the direction. This is the direction. Okay, so this is the direction from your right above the line. It is not below the line. Okay, if you write from your left, that will be wrong. Okay, from your right above the line, you see for each and every case here also, if this is the dimension line, from your right, that means from this side above the line I have written the value. So this is the way how to denote by the aligned system. And here also you can see 516 I have taken out the same manner I have shown. Arrowheads are there, small arrowheads you can see. With the help of leader line I have taken out this dimension outside the object. I have written 516. That means diameter of this circle is my 16 millimeter. Okay, so this is basically the aligned system. Okay, and this one is your unidirectional system. This also you can see what is the difference. You can see the difference here also. The extension line and dimension line will be there, but the dimension line will be broken at the middle. Okay, that would be a gap. Okay, at the exactly at the middle you have to write the value of the dimension. Okay, so I think that I personally think this aligned system is much more easier compared to the your unidirectional system. But again, it is up to you. But if you are following aligned system. Throughout the drawing you have to follow the aligned system. And unidirectional, you can see here there will be no from your right above the line, there will be no rule like that, but this value should be written at the middle. Okay, like this. If you can do that, you can go for the unidirectional system. I have no problem. So these are the basically two types of lines that you have to sorry, two types of your dimensioning that you have to know. Dimensioning is very important. Okay, if you do not give the dimensions after drawing anything, that there is no value of that particular drawing. Okay, marks will be automatically deducted, because any product, if you do not give the dimension, the manufacturer cannot manufacture it. Okay, if they don't know the length, height and everything, okay, each and every dimension you have to mention by this proper way. You are not supposed to use your own way. Okay, so this is all about the dimensioning, right? This is not required as of now. Okay, now I am starting the scale part. Scale is basically you have used scale. This is basically your regarding assignment number one, problem number one. The last 15-20 minutes whatever I told, that is basically introductory part again, but that will be required. That is very very important. Often we have seen students are not following the proper dimensioning, students are not following the proper fonts. Okay, that means proper lettering, numbering. So that's why I have spent some time on that. Now let us start with scale. Scale is basically you have used whatever the scale in your day-to-day life. I use scale in our for our study and for our geometry. Okay, we use scale. And can you tell me what is that type of scale is? Do you know that what is that type of scale?
Centimeter scale, sir.
Centimeter is a unit. Okay, so you may not be knowing the
Linear
exact.
centimeter scale.
Yeah, centimeter or inch, that is the some units that is graduated on the particular on the surface of that scale. But that type of scale is basically known as your plane scale. Okay, so whenever you are using plane scale, why it is called, basically different types of scales are there. I'll show you. But what is the importance of this scale to learn over here? Okay, I think in the introductory class I told about some designs. Okay, scale ratio I have discussed, I think, in the introductory class, last class. That means there I have mentioned that if I have to manufacture anything, I have to design it. Then if I have to design it, I may have to reduce the dimension of that particular object, or I may have to increase the dimension of that particular object, whatever I want to manufacture. Now, when I am drawing, if I am reducing by a particular ratio, that ratio is basically a scale ratio. It is called a scale ratio. So with a particular ratio, I am reducing all the dimensions, or with a particular ratio, I am increasing all the dimensions. Okay. So that is a practical importance of any scale. Okay, or this concept of scale. But here, what type of problem we will solve? Basically, one particular problem will be given, and we will try to construct a scale. I repeat, we will try to construct a scale depending on a problem. Okay, problem will be given to you. Say for a problem of a map is given to you. Okay, in each and every map you are having a scale. Okay, you know that. So that type of scale we will create. So scale is basically it may be actually this ratio, whatever that ratio, scale ratio I was talking about, that is also known as representative factor. That ratio, uh, I'm coming to this representative factor, don't worry. What is this representative factor? This will be used to draw the scale. And the importance of the scale is that for any design it may be used. Either I'm enlarging any dimension for my design purpose, or I'm reducing. If I'm enlarging any dimension of any object, that type of scale is known as your enlarging scale. If I am reducing the dimension of any object for my drawing purpose, that type of scale is known as your reducing scale. So as you don't know this definition of this representative factor, you just cannot understand these ratios. Let me tell you first what is representative factor, then I'm coming to this ratio point of view. Okay, use following formulas for the calculation. First step, if you are having a problem of scale, I will show you a particular problem how to generate scale. But there are two main steps to draw the scale. First one is the calculation of this ratio. Okay, what is this ratio? It is known as your representative factor, RF. In short, it is called RF. What is this RF? It is my dimension of drawing divided by dimension of the object. Fine. You can see here dimension of drawing divided by dimension of the object. Now if you see, just for your example I'm telling, if the dimension of drawing is much less than the dimension of the actual dimension of the object, then this ratio will be, that means let me write here some value. Say I am having 1 each to 10. I am saying that RF ratio is my 1 each to 10. Okay, that means what? That means the dimension of drawing, if it is 1 unit, my actual dimension of the object is my 10 unit or not? This point is clear.
Yes, sir.
Yes,
Yes,
sir.
So
sir.
then in drawing what I am doing, I am reducing the dimension. I am reducing that 10 unit into 1 unit or not, right? Because in I am having 1 upon 10, say for example. Okay, here, so dimension of drawing I am having 1 and actual dimension is my 10. So what I am doing, basically I am reducing the dimension, actual dimension I am reducing for my purpose. This type of scale is known as your reducing scale. Okay, whenever from this value of this RF I can say my scale is reducing scale or enlarging scale. But if my this ratio, if this RF ratio is my 5, say for example each to 1, what is that type of scale?
Enlarging.
Enlarging scale. That means 5 each to 1 means this 1 is my dimension of the object. Okay, that means the actual dimension of the object, and 5 is what? 5 is what? My dimension of the drawing. That means I am in the drawing, I am just enlarging the dimension. So these are the two ways. From the ratio I can say that it is my enlarging scale or it is my reducing scale. This point is clear to all of you or not?
Yes, sir.
Yes, sir.
It's very basic, but in Viva it is asked, my, say for example RF is my 1 is to 20. What is the type of scale? The type of scale is nothing but my your reducing scale. Okay, so in that way you have to understand, just you have to know this definition. Okay, you have to know this definition, that what is RF? Basically dimension of drawing divided by dimension of the object. So it may be of three types. Three types means the dimension may come in terms of length, that the dimension may come in terms of area, or it may come in terms of volume. So only the equation is getting changed. If you see, if it is in terms of length, it is my length of drawing divided by the actual length. And if it is in terms of area, under root of area of drawing divided by actual area. If it is in terms of volume, cube root. Okay, you can see over here, it is my cube root of volume as per drawing divided by the actual volume. Now it depends the data that is available in your problem, that is in which term, it is in terms of length or area or volume, and you have to calculate the RF. That is the first step of construction of any scale. Next step is to calculate the length of scale. Okay, what is the length of scale? Basically whatever the length you will take, okay, for your drawing purpose, that length, it is called LOS, length of scale. Okay, you just take a note of this this equation. As of now I'll show you while I will solve a particular problem. Length of scale means the length that you will draw in your drawing page. Okay, of just you are supposed to construct a particular scale, so you have to take a length for that. That length is your length of scale. It is what? RF that you have calculated right now, RF multiplied by maximum length to be measured. Now each and every scale is having some limit, because whatever the scale you are having in your hand, say for example if it is a small scale, it it may just measure up to 15 centimeter, not beyond that. So that is the maximum length to be measured. So that type of maximum limit will be also given in the problem, and if you multiply those two values, RF into that value, you will get the length of scale. Okay, these two equations are clear or not? I'm showing the application of these two equations in a particular problem,
Yes, sir.
but you have to know this equation. These two equations will be required for solving the scale problems. Okay, now before going to a problem directly, I should show you the units. All of you know this, still you have a look. I'm not reading out this because all of you should be familiar with these units, because we'll play with different units in this chapter. So starting from kilometer up to millimeter, you can see the conversion. And types of scales, now these types of scales you have learned as of now: reducing scale and your enlarging scale. That is depending on the value of RF. But as per the capability of, I should say, the measurement capability of any scale, it may be of different types. That means plain scale, it is used for up to single decimal. That means I'm giving you example. Whatever the scale you are having with you in your geometry box, if I ask you to draw, say, 5.1 centimeter, you can measure, right or not? Just you can measure 5.1 centimeter easily. But if I ask you to measure 5.27 centimeter, can you draw? Can you take that much of
No,
length?
sir.
That is not possible,
No, sir.
because that is not allowed in that scale. That means up to 2 decimal it cannot measure. So for that we may need diagonal scale. Okay, this is the type of scale, diagonal scale. This problem we will discuss how to construct a diagonal scale. Basically these two scales are in your syllabus, plane scale and diagonal scale. And if you understand a problem of diagonal scale, that will automatically cover this plane scale. Okay, so that's why I will show you one problem from diagonal scale. So that may you can see the dimensions up to 2 decimal, it can measure diagonal scales. And vernal scales also can do that, but it is used for smaller dimensions. I think you have used these type of scales in your school level in your physics lab, vernier scales. And comparative scale is what? The comparing two different units. Okay, in a single scale, say for example I'm having centimeter also, I'm having inches also, as you are having, that scale also may be called comparative scale. That means you can compare two different units in a single scale. Okay. And last one is the scale of squads. It is basically, it is used for measuring the angles. Okay, measuring the angles or any angular dimensions to measure. This is known as your scale of chords. But your concentration should be in first two, plane scale and diagonal scale. Okay, but you have to know these names at least. Okay, so now let me show you a problem of diagonal scale, not a plane scale. I will not show you a problem of plane scale. I'll show you directly a problem of diagonal scale, so that uh, that will cover the plane scale part. Okay, first you read the problem. Okay, similar type of problem you will have in your assignment. The distance between Delhi and Agra is 200 kilometer. That means it is my actual distance between these two places, Delhi and Agra. In a railway map, it is represented by a line of 5 centimeter. Then who can tell me which one is the dimension of drawing and which one is the actual dimension? Which one is dimension of
The
the drawing?
actual dimension is a
Huh?
actual dimension is a 200 kilometer,
Yes,
and the dimension of drawing is 5 centimeter.
5 centimeter. That means I am having a railway map, okay, in which if I place a scale between these two cities, I am getting 5 centimeter, okay, length in my scale, okay, plane scale. But from these two informations, I can calculate this value or not, the representative factor or not. I can easily calculate.
Yes, sir.
Because I am having dimension of drawing, I am having actual dimension. So I can easily calculate this representative factor, RF. Then I have to draw a diagonal scale to show, very important, read this line very carefully. Draw a diagonal scale to show single kilometer and maximum 600 kilometer. Okay, that means this is the maximum limit, 600 kilometer, that I was talking about. The maximum limit should be given in the problem, that is your this 600 kilometer over here. That means beyond 600 kilometer, whatever the scale I will construct, that cannot measure. Okay, that is given in the problem. And after constructing the scale, I have to mention these 4 distances on that particular scale. Okay, so that is the last part. I'll show you. Let me show you the construction first. Okay, this is the first two calculations that I have to do. 5 centimeter is the dimension of the drawing, 200 kilometer is the dimension of these two cities, actual dimension, and change the unit in a single unit. That means convert this kilometer into centimeter, and it is coming a ratio like this. Okay, keep it in terms of ratio. So length of scale will be what? This RF multiplied by which distance? Tell me. RF multiplied by
600. 600.
600 kilometers, because that is the
600.
maximum distance I have to measure as per this problem. Okay, So 600 again kilometer I have to multiply with 10 to the power 5, so that it is just I am converting this kilometer into centimeter, so that I am getting this length of scale directly in terms of centimeter. So this 15 centimeter I have got. This is the length of scale as per this problem. So this 15 centimeter I have to now take. Okay. So these things just ignore. You just listen to me so that you can understand the steps. These are some steps are written. Okay. This length, this straight line is how much long? 15 centimeter. That length of scale I have denoted 15 centimeter. I have calculated. So that 15 centimeter is nothing but this one. Okay. So this 15 centimeter is actually denoting how much kilometer? Anyone can tell me?
600.
600 kilometers.
100 kilometers.
Very good. It is my
600.
600, 600 kilometer. That means I am drawing 15 centimeter, but I have to keep in my mind that this is nothing but 600 kilometer. In this fashion, you have to just understand the problem. Now, say my goal is what? My goal is to measure these things, right? 222, 336 kilometer. Okay, like this. So, if I just want to measure for your reference, I am just telling 222 kilometer. That means I have to write like this: 200 plus 20 plus 2. Okay, in this way I can just measure it. So first thing I need 200. That means I need a distance which is a multiple of 100. How can I create that? This is my 600 kilometer. Okay, you see, if I divide this 600 kilometer distance into 6 equal parts, each of the part will give me how much? 100, 100 kilometers. So now you just forget about this 15 centimeters. Student make mistake in this step, that I have drawn 15 centimeter line, so I have to divide this line into 15 equal parts. No, that is wrong. How you have to decide that in how many parts you divide? From this maximum length. Okay, maximum is how much? 600. So this is my 600 kilometer. This 15 centimeter line is nothing but 600 kilometer. And if I need a multiple of 100 kilometer, that means I have to divide this line into 6 equal parts. Is that clear to all of you?
Yes, sir.
Sir.
Yes.
Yes, sir.
Okay. Okay. So each of the part will be your 100 kilometer, whatever the division. Now, how to divide this line into 6 equal part? That process I will show you in the next class. That is a process known as your set square method. That is known as your set square method. Using the two set square that you have bought, we have to divide this. Okay. Into, not by scale. You have to follow a process here that is not shown. So I have to divide this line into 6 equal parts. Now I will number it. How? Like this. I will start 0 from here. I will not start 0 from here. Why? You will understand after some time. I will start my 0 from here and I will write 100. That means first part is 100. Second part is again 100. So 100, 200, 300, 400, 500. And the first part that I have left, that is also 100. So total is my 600 kilometer. Okay. Now, so using whatever the length I have, whatever the scale I have just created, so if I want to measure 200 kilometer, I can measure it. How to measure? This is my 0. From 0 you have to start. Any measuring you have to start from 0. Okay. So from 0, 100, 200. That means this distance is your 200 kilometer. But if I need 20 kilometer, what I have to do? I need a multiple of
Divided
10.
in 5 parts again.
Yes, that means this first part, whatever I have left, that is also 100 kilometer. I have to divide that 100 kilometer into 10 equal parts again. You can see the small parts. You can see these small parts.
Yes, sir.
Each of the part is your how much? 10
10
kilometer or not?
kilometers.
Because
10
100
kilometers.
kilometer I am having. Yes, very good. 100 kilometer I am having. I am dividing this small part into 10 equal parts. Okay, so that each of the part is your 10 kilometer. Okay, so up to this whatever the construction you have seen, the main division and the division of the first part, up to this if you construct a scale, that is known as your plane scale. That means if I create a scale like this, if I take a height like this, okay, and if I draw a rectangular block like this is my plane scale. So this third part I cannot measure by the plane scale. Okay, that means 220 kilometer I can measure. 220 kilometer I can measure. How much it will be? 220 kilometer. From this 0, for this 200, I have to go to the right. 100, 200. Draw a line over here. Okay. Draw a line means just this. I'm just showing you the link from the 0 up to this 200. That is my 200. How can I get this 20 kilometer? From 0, if I go to left,
Sir, from the first division.
from 0, always remember, don't mistake that from this, don't track from this point. Always start from this point. Okay. From 0, I have to go to now left. First part, if I go, that is giving me 10 kilometer. Second point, if I go, that is giving me 20 kilometer. So from this point to this point, it is my 220 kilometer or not? This in between
Yes, sir.
distance,
Yes, sir.
it is my 220 kilometer. That is the example of your plane scale, right? But if I am trying to draw a diagonal scale, I have to modify a bit. Okay, so up to this, I think it is clear to all of you. Okay, now from this point, from the last point, that means from this end point, you take a height. Okay, you take a height. How much this height will be taken? There is no particular rule for that, but it should be approximately equals to this first part, or it should not go beyond 4 to 5 centimeter. Maximum 4 to 5 centimeter you should take, not beyond that. Okay, so take up just convenient height, okay, and complete this rectangle so that it looks like a scale. A scale should look like a scale, because if you take the height up to this, say up to this, obviously that is also not technically wrong, but that will not look like a scale, right? So take a convenient height and complete this rectangle. Next, whatever the height you have taken, divide, okay, these vertical lines you can take, okay, from these divisions. That division already you are having to draw these vertical lines,
Sir, each of same length.
each of, yes, obviously,
Sir,
yes, obviously, each of your same length, okay, each of these lines, because this is a rectangle. Okay, and whatever the height you are having over here, this height, divide that height also into 10 equal parts, like this. This how to divide, again I will show you in the next class. That is your set square method. This horizontal division you have divided earlier into 10 equal parts. Okay, this height also, whatever you have taken, that also you have to divide into 10 equal parts, that you can see 0 1 2 3, and it will run. This end point is my 10th point. Okay, up to this clear or any doubt?
Yes, sir. Clear.
So
Sir,
here you can see that here the horizontal lines has been drawn from each of these divisions. 10 equal parts I told, the vertical part 10 equal divisions. You can see the horizontal lines has drawn up to the end. You may not draw up to the end. You can just draw just this up to this first part. Okay, first box. You can draw this horizontal line up to this first box. That will be enough. Now, last and important step, that is the name of the line is my diagonal scale. You can see here. So here, take the ninth point. This is the ninth point. This is my 0 1 2 3 4, and like this is my ninth point. From the ninth point, okay, these are the units they have mentioned. Yes, this line I am talking about. From this ninth point, join the 10th point or the topmost point. From this ninth point, join the 10th point, okay, by your scale, so that you are getting a diagonal line, and draw parallel to this line at each and every horizontal division. These are the horizontal division in the first part. So draw parallel to the first diagonal line in each of these horizontal divisions, up to which, up to 0 point, up to 0 point. How to draw these parallel lines? Using your roll and draw. Using your roll and draw instrument, you can draw these parallel lines. So first join this ninth point to this 10th point, so that you will get this your diagonal line, and then draw parallel to that line in each and every these points, horizontal points, up to the 0 point. Okay, so this completes the construction of the diagonal scale. Okay, diagonal scale showing in kilometers because all the units are in kilometers. Now you can find this 222 or these dimensions. Okay, how to find? Listen carefully, it will take 2 minutes. I will finish up the class. 569, for example, 569 means, as I told, how I have to take 500 plus 60 plus 9. Okay, so try to understand over here. 500, how can I take 500? From 0 I have to start, I told. Okay,
5.
from 0 up to this 500, that will give me 500 kilometer. Draw a vertical line like this. Outside the scale you have to show. Okay, draw a vertical line like this. Next is my 60. How can I get 60 kilometer? From 0
The left and zero.
I have to go to the left up to the sixth point. That will give me 60 because each of this part is 10 kilometer. So first, second, third, fourth, fifth, sixth. This is, see my arrow. Okay, okay, see my cursor. That is my 60 kilometer. And 9. How can I get the 9 kilometer? You see, at this sixth point, you are having a diagonal line. At each and every point, you are having diagonal line. So this is my sixth point. Take that diagonal line from that is emerging from that particular point. Take that diagonal line and go up to the ninth point. Okay, I'm repeating this step. From 0 for 60 kilometer, I am going to the sixth point first. That is giving me 60 kilometer. Then 9. How can I take the 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is the ninth point. Mark that point. In between distance is nothing but 569 kilometer. Is that clear to all of you?
Yes.
Yes, sir.
I'm showing
Yes,
again.
sir.
I'm showing again for another dimension. Those who have not understood, please listen again. So 459 kilometer means 400 plus 50 plus 9. 400 means from 0, I'll start from 0, 0 to 400. This is my 400 kilometer. Okay. 50 means from 0, I have to go to where? I have to go to left. Okay.
Left 5 unit.
Left fifth point.
The left side.
Okay. This is the fifth point. How can I get 9 kilometer? At this fifth point, I am having another diagonal line. I will take that diagonal line and I will go up to the ninth point. Mark that point, and in between distance is nothing but 459 kilometers. I think it is clear to you. And if still someone is in doubt, you can refer the I'm recording this lecture. I'll share in your Google Classroom. You can listen to it later also. Okay, it's very easy. After construction, you have to mark this type of dimensions in your scale, and you will find similar problem in your question number 1 of your assignment number 1. And let me quickly show you the this your other two also, 336 and 222. So 336 means 0 to 300, that is my 300 kilometer. 30 means from 0 to 10, 20, 30. Okay, this is my third point. 6 means 1, 2, 3, 4, 5, 6. This is the point. See my cursor. Draw a vertical line from that point, and outside the scale write 336 kilometers. And the last one is 222 kilometers. That means 0 to 200, that is my 200 kilometer. 20, 10, 20, from 0 I'll have to go to the left, and 2 means first point, second point. Okay, from this point I will draw a vertical line, and in between distance is giving me 222 kilometers. Is that clear, this problem, all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Thank
sir.
you very much, okay, for attending. In the next class we'll show you more, okay, in the curves and the set square method and all I'll show you. Okay, so I'm ending this class here because your AutoCAD class will start right now. Okay, so thank you for attending. See you in the next class.
Thank you, sir.
So there will be no assignment, right, for the next class?
No, for the next, because we are starting the assignment number 1. Problem number 1 we have solved. Okay, basically if you see the problem number 1, it is similar to the problem that I have solved right now. Okay, so try to solve that by own in your sketchbook. Okay, and try to construct that diagonal scale also. And in the next class we will continue the assignment number 1. Okay,
Okay, sir.
thank you. Attendance link will be given in the AutoCAD class at proper time. Thank you.
Thank you, sir.
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 Thank you, sir.